Hello, everyone. For those of you who do not know me, I am Brian Wolff. I've been around the MediaWiki community for quite a long time now, and currently I work at WikiTech, which is a MediaWiki consulting firm. Today I'm going to talk to you about debugging slow wikis and what to do when you set up your wiki and suddenly it's slow and you're not sure where to go from there. So first of all, I'm just going to switch the camera. Cool. Okay, so as I was saying, you set up your wiki and suddenly you realize it's just really slow and sluggish and you're not sure what to do about it. So in this presentation, I'm going to talk through what things could go wrong, what to look into to see what has gone wrong, and kind of what to do about it. So at the very basics in MediaWiki, some of the most important things are ensuring that the object cache is enabled and the parser cache is working. These are usually the top things to look at from the very get-go, as they have a dramatic effect on performance. In general, when you're trying to figure out a performance problem, it's always very important to measure what you're doing. It's so very easy to just have some sort of theory in your mind of what you think is the problem, what you think is causing the badness, and go fix it. But then it turns out you were wrong. That wasn't the slow part, and you just spent like a week fixing something that wasn't broken, and that week is wasted. So, as they say in the lumber industry, measure twice, cut once. Always measure, always verify that what you did had the effect you thought it would. So since we're going to talk kind of starting from the basics, the most basic part of performance is system resources, and do you have enough of them? Oftentimes, the first thing people go to if something is slow, buy a better computer. And sometimes that is the correct answer. Sometimes it's not. It can all kind of depend on what is wrong. As I said, you should measure first, but the first thing to measure is your system resources being overutilized? Do you just not have enough, or is there some configuration problem causing them to be overutilized? So to first do that, we should measure. One possible command, there are many, on Linux is vmstat, gives you kind of an overview of how your Linux system's memory, CPU are currently being utilized. Certainly not the be all and end all, but like just as a quick 30-second glance to see what is overutilized, it can be really helpful starting place. The output is a little bit, you need to decode it, but the big parts are look to see if your memory has too much free memory, look to see if your swap is being in use, and look to see how much of your CPU is being used by user processes. If you're out of memory, your system will start trying to use swap memory, which is fake memory. And typically when that happens, everything goes to hell. So you do not want that to happen ever on your server. So if you look at, there's also the swap column there, how much free memory you have. If it's a low number, you need to reduce the amount of memory being used by different parts of your system or add more memory. And if your memory is fine, you can look at CPU time. Is CPU time close to 90% all the time? That probably means your CPUs are all utilized, and you either need more or you need to maybe adjust your caching so that stuff can be reused so that the CPU can have a bit of a break. As I said, swapping is bad, and make sure you're not doing that. But if you do run out of memory, oftentimes, especially for smaller wikis, a lot of different things are probably running on your server. You probably only have one because you're small, right? And the different things often have controls to control how much memory they're using. The big ones are your caches can have configured size. If they're too low, they're useless caches. If they're too high, you run out of memory, and that's even worse. Similarly, web servers, like number of clients, number of web things processed at once can increase your memory if it's doing like 200 requests all at the same time, instead of doing a small number of requests and then going to the next one. And a variety of things. Elasticsearch can be a huge memory hog, that sort of thing. Top command, I'm sure you're all familiar with it, shows on Linux the top processes, usually by how much CPU they're using, but it can also be used to show what is the top memory hogs. Like in this example, Java is the top one. Maybe you might think MediaWiki is written in PHP. What does Java have to do with it? But Elasticsearch is written in Java, and this particular server uses Elasticsearch, and that takes up a lot of memory. Similarly, Redis is an object cache, and cache main on this list is the name of the varnish process. This can kind of get you an idea of what's using the most memory, what maybe you could cut, and if something is in a place on this list you don't expect it to be, it's a good thing to look into. The other thing you might have, maybe your memory is fine and you see your CPU usage is really high. This is actually a pretty common thing in smaller MediaWiki instances. In MediaWiki, when your CPU is high, it usually means you're parsing pages kind of over and over again. And MediaWiki parsing is what we call the process that turns wiki text into HTML. And when you're using complicated templates, that can take a lot of time for MediaWiki to convert them to HTML. Typically, this is a process that we have something called the parser cache, which saves the result of turning something into HTML and then reuses it next time instead of doing it every single time. But there's a bunch of ways that might not be effective. There's many extensions which disable it because they want to show something different for every single user. Or sometimes they might decrease the time. Like if you put in a page something like the current time, it might decrease the amount of time the parser cache is used for because it wants that to be updated. For wikis that have a large distribution of requests, where a small number are logged in users editing, but a larger number of people just looking at it, not all wikis fall into this, but some really do. Varnish can be super helpful. For those not familiar, Varnish is a program that basically saves the result of your entire page. And every time someone visits your website, if they're not logged in, and so it doesn't matter, you don't have like your username at the top or other user-specific customizations, it can see not logged in, it can just send the same page that the last person got, even before hitting PHP or MediaWiki. And that can be a big improvement for wikis with a lot of anonymous users and good latency improvement too. The other thing that can really help with MediaWiki taking a lot of CPU usage is rewriting templates using Ubuntu, which is what we call Lua templates. A lot of wiki text related functionality is very slow, especially some extensions like extension arrays is often very slow, and just rewriting it in Lua can often result in a rather big speed increase. So diving a little bit deeper, I'm not sure how many people are familiar with this. Don't worry if you can't read it. I know it's small. But on every page in a MediaWiki instance, if you go to the HTML view source, there's an HTML code comment talking about the wiki text to HTML conversion process, what we call the parser new PP report. New PP stands for new preprocessor. You don't even know what that means. But it has a bunch of data about how the process went, which is super helpful if you're trying to figure out why the process is slow. There's a bunch of different things on this list that is way too small for you to read. Most definitely, big ones are the cache expiry, like how long the cache is used for. If it's only used for 5 minutes, it's kind of useless. Default is about 24 hours. And lots of people, maybe you want a higher default than that, it might make sense. Other things, CPU time versus real time. CPU time is how much time of the page rendering was spent on the CPU versus other things. This can be helpful if you have like extensions that are reaching out over the network to, I don't know, maybe include some external API data or something in it. If the network is taking a long time to respond, that will slow down page loading, but it won't increase CPU time. It would increase real time. So seeing how those numbers compare can also really help kind of diagnose the problem. At the same time, if you have like a lot of requests and your Apache is set up to try and parse a lot of them at the same time, and they're all fighting over the CPU, that means real time might be really high and CPU time will be really low because the actual time spent rendering the page is small, but it was split amongst like 30 different processes all trying to render a page at the same time. Other big ones is there is a template profile which says which templates took the most time to render. You probably can't see it here. This is an example from Wikipedia and showing that the refless template is the most expensive template on this very small page because it took 500 milliseconds or about 30% of the time. As I said earlier, it's always important to measure first, and it's always important to choose the big things to fix. Like for example, on this one, there is template short description. It took 2% of the time and 49 milliseconds. You probably can't improve on that much, but let's say you could. Is going 49 milliseconds to 10 milliseconds really going to make a difference to anyone? Like, that's less than a blink of an eye. So there's no point spending a lot of time trying to fix the small things. Always try and fix the big things. Yeah, as I said, transclusion profile, CPU time versus real time, reduced cache expiry. There's some other fields here, and some of them are useful, but they're not like the core, things to look at first. So yeah, that kind of brings me to the next point. Often, if you see a slow thing and you've ruled out your out of memory and swapping, and you've ruled out various like CPU optimizations or caching is wrong, next thing to do is try and optimize the templates. Often this is the most applicable thing that you can change. Often, like sometimes you can buy a server with more CPUs, but that costs money, and maybe servers are expensive, or maybe it's someone above you in the organization's decision what type of server to run. But most wiki admins, they can always edit a template. So extension arrays is very slow due to the way it works, like surprisingly so. That's a big one to try and replace with something else if you're using it, especially Ubuntu, because Ubuntu has much faster control structures. Beyond that, Ubuntu can do other things, especially kind of reusing data. Sometimes extension variables is used for this purpose. I definitely recommend Ubuntu if possible. Variables can make hard to maintain extensions to see what's going on, and also has questionable forward compatibility. Other things to think about, a common thing people talk about is database intensive extensions like Semantic MediaWiki or Cargo. I know there's a lot of fans of those in the crowd. And those can be a source of slowness, but they're more like extensions that scale poorly. So when you have a small wiki, which is a large number of people, there's some people who run big wikis, lots of people run small wikis. If you're running small wikis, you can do anything to the database. It won't matter. It always starts out fast if you have less than 20,000 pages. It's just Semantic MediaWiki, Cargo, those sorts of things tend to get slower faster, if that makes sense. If you go from 20,000 pages to 100,000 pages, it starts to slow down significantly. So when you're small, it's all good. And then as you grow, it's more to worry about that. As always, you should measure first. And there are things you can do to try and optimize Cargo and SMW, but they're kind of more complicated and depend a lot more on what you're specifically doing. Now, profiling. If after all this, you're still not sure what is being slow, the true way to see what is kind of going wrong is profiling. For those who aren't familiar with the term, it's when you take a computer program and you basically record for every function how much time it took and how many times it was called. This can get a little technical and can be a little harder to interpret, but it gives you the most data. As you can see, profiling in MediaWiki is pretty easy to install. You have one PHP extension you have to install, PHP Tideways. If you're using Debian or Ubuntu, that's an apt-get install away, very easy to install. On some other operating systems, maybe a bit harder, but ultimately it's not that hard. One thing to look out for is there are multiple Tideways extensions. There's a commercial one and there's a free one, and you want the free one. I mean, if you're into the commercial one, I haven't used it. I hear it's good, but I personally want the one I don't have to pay for. And honestly, it's kind of all you need. And then there's like 3 lines of MediaWiki config. The last line tells it whether to put it in an HTML comment or just display it right on the page. I usually use an HTML comment. So to give you an idea of what this looks like, it looks like this output. And this is split over 2 columns just for ease of reading this. And like when you first see this, you might be like, what is this? It's kind of quite technical. You maybe recognize some of the words, you're not sure what they are. So it can be a bit of a learning curve to kind of understand this and know what it means. In this particular example, some things I highlight is you have like pool work article view. That's the part that makes the page. And as you can see in this example, it's taking 97% of the time. It's taking 7,000 milliseconds or 7 seconds, and it's called once. So that's a sign that your slowness is caused by something in wiki text in rendering the page. You might have a different situation where maybe an extension is causing your slowness that's not tied to wiki text. In that case, page rendering probably won't be 97% of the use case. So now you've kind of ruled out all sorts of other causes. The other thing to note in this particular example, which is kind of an example of a slow page that's just kind of slow due to complex templates, you have a lot of SMW things right at the top. The first thing you might think is maybe this is an example of the semantic MediaWiki database is kind of like struggling and like it's the complicated database queries. But the other thing you notice here is there's no actual query functions in the top. Like MySQL query is not anywhere near the top. So the conclusion you can kind of draw from that is something about SMW is slowing things down, but it's not the database access. And while you can't quite tell from here, the next step is probably to look at what your templates actually do. And in this particular example, it's a SMW template that does a query and uses the template format parameter to call a template for each item returned in the query. And that template was like a very complex template. So this example turns out to be a complicated template. And this was a real example, and we optimized the template, and it significantly reduced the time the page loaded, because that was the key. And basically our optimization was rewriting it in Lua, but not really changing much about the logic or how it works. We found in this particular example, it was using kind of nested the arrays wiki text extension. And that extension, due to how it processes wiki text, can be quite slow. And rewriting basically the exact same logic in Lua made it significantly faster. I think took it down to something like 2 seconds to render the page. So just straight up rewriting in Lua without doing any kind of like fussy code optimizations can really help the template render time. So I have a second example to kind of show you like the different things you might see in a profile. So this is, again, another real example. We found a page was slow and we weren't sure why, so we ran a profile. And we noticed something weird. We saw that like all the parser pool work article view do work was called twice. It was still taking 100% of the time, so it's something to do with page rendering. And it was taking 29 seconds, but it was called twice. That's weird. You're viewing one page, right? Why would you have 2 page renders? We also noticed going down that almost exactly 50% of the time was being spent in this one extension hook, which is very suspicious, like precisely 50%, and the page is being rendered twice. What turned out is the extension was inadvertently triggering a double render of the page. So this one was tricky, and when I actually looked at the code of the extension, the first time I looked at it, I didn't understand why this was happening. For context, there's this extension. It had like a magic word in it for the current user, but it didn't want to disable varnish cache when users aren't logged in because it didn't display a username, but it did need to disable parser cache for the logged in users. So it didn't want to use the default MediaWiki way of disabling because that would disable both caches. So it tried this custom thing, where it got the article and it looked at a flag. A flag is something you can set when rendering a page. And it basically checked the flag to see if that page used this extension. And if so, it disabled the parser cache. And this hook is run before the page is displayed. So this sounds great, but what we didn't realize is when we're coming into this, we have to get the parser output to know if this extension is used the page. So to figure out if this extension is on the page, we need to render the page. So we render the page, and then we see that this extension is on the page, and we say, well, don't use the parser cache. And then we hand it off back to MediaWiki. MediaWiki says, can't use the parser cache, so can't use that rendering I literally just did 5 seconds ago. Let's do it again. And as a result, pages were rendered twice and took twice the amount of time that they could have. Obviously, in this example, it was 29 seconds, and it brought it down to 15. That was still slow. There was other things like complicated templates, but it was a major, a small change that had a major impact. And we switched it to use a different cache splitting mechanism. So I'm doing, oh, I have lots of time. I guess I talk fast when I'm actually up here. Okay, so our last example, because I know these get boring if you look at too many of them, but I wanted to kind of show the different things you can see, because profiling is really technical when you start to see it, and it can be hard to kind of make sense of it first. So this is another real example. There was an extension that fetched some stuff from a foreign API, some external data, and injected it into the page. And we ran the profile on this page. The extension we thought would have been cached, so we didn't think it should take up that much of the page. But when we ran the profile, we saw that the extension was taking 30% of the time. And as we looked closer, we realized the extension was called 17,000 times during the rendering of that page, which was more than we expected. We knew the extension was used a lot in the page. Like, we knew that going in. We didn't quite know it was 17,000 times. But what more, we were originally worried that the extension was making this HTTP request every time, or something like that, and that was causing the slow. So that was our theory going in before we measured. And this is why measuring is important, because it turns out the HTTP request things are nowhere near in the profile. So it's not requesting, it's fetching it from cache. We saw the cache lookups up there in the profile, but all the entries were cached, and it was still slow, but it was doing it 17,000 times. And when we look closer, we noticed that set cache was being called 16,000 times, which is a bit odd. Like, you know, normally you set the cache when you generate a new thing. You don't set the cache when you're getting the thing. So it turned out there was some kind of small logic errors in how the extension was managing cache. We replaced the kind of custom way it was managing cache with, I'm not sure if you're familiar, in MediaWiki there's a class called WAN Object Cache, which does a lot of things for you, very smart and very optimized for doing things right. One of the things it does is if you're fetching something repetitively, it kind of saves it within the process, so you don't have to hit the external cache. Like, hitting an external cache, in this case Redis, is quite fast, but it's still like a request. And when you do it 17,000 times, it adds up. So using WAN Object Cache, which automatically keeps the last, 10 things you requested from cache around, that was a massive improvement. It also allowed faster regeneration instead of this, because the previous thing was kind of setting the cache all the time. This one only set it when you need to, and also check to see if it's almost expired and tried to reset it back. It did a bunch of fancy stuff. And replacing it with that small change significantly improved the time, even though in both cases we were doing a cache resolve, but this was a smarter use of cache. Cool. So yeah, basically to conclude, always measure again and again to make sure you're doing the right part. If that's one take-home message, always measure when something is slow, and always try and fix the big part, the big slow part, not the fast part. It's always important as a starting point to make sure that your system resources are in order. Of things I've seen of kind of third-party wikis that are slow, almost like 90% of the time is some sort of memory issue. Often it's like out of memory, and then some bot comes and tries to render 90 pages, and Apache is configured to, like, in its fork mode to spin up to 600 children, and eventually all the RAM runs out, and then swap starts happening, and that slows everything down, and it's kind of like a positive feedback cycle because things are slow, so more requests pile up. So lack of memory usage. And then the other thing that I often see is like CPUs maxed out, again, because maybe some web spider bot. I don't know if you've ever heard of SEMrush bot. It seems to be a common one that tries to render everything at once. And MediaWiki is just overwhelmed trying to render every page at the same time. So yeah, if your wiki is slow, also check your log files, see if bots are hitting it repetitively, and like block them all. But after you check that, look at templates and try and improve them, and look at profiling to make sure you understand what the slow parts actually are. And of course, this is kind of like just the basic top level first things to do. And there's an entire different conversation from going like, things are way too slow to making them acceptable versus going from acceptable to like, this is great. There's lots of research that latency really affects people subconsciously. Like I think Amazon or whatever did research. I don't remember what it was, something like 30 millisecond difference is like a 1% sales difference. Like making things faster really does help, but going from bad to okay is really different than going from okay to great. And that's a totally different topic. However, people at the Wikimedia Foundation, especially Timo, have written some great documents about what the foundation does to try and improve that, and they're really good learning resources for that sort of thing. I highly recommend you read them if you're interested. Cool, and that's pretty much all I had to say. I was wondering if anyone had any questions. No? Yes, Jeffrey?
So those of us who work in industry and publish a lot of code know that CI/CD is a great way for us to enforce, testing to ensure we don't have any regressions. And performance testing is kind of tricky because it falls squarely into integration testing, but it's really tough to write so many tests to the point where you can catch every single edge case. So what do you think is the best way to enforce performance testing like this without making it, like take up half your time of development?
Yeah, that's a good question. So just to repeat the question so people can hear, Jeffrey asked if like standard practice for like things where you want to enforce something is to have continuous integration testing to enforce them, but it's hard to write tests for performance and catch all the things, and kind of what do you recommend? So I agree that performance testing is hard. For the reason you mentioned, it's hard to test every possible thing, but it's also hard to make realistic performance tests sometimes, because like, your CI server's not a real server that like follows real user patterns. And like, sometimes there's mistakes that are like, you're going to get caught no matter what type of testing you do. But performance is one of those areas where it really does matter how your users access your site. So there are some bots you can do. Like I know Wikimedia does have performance continuous integration testing. I think it's called like Fresnel or something. My recommendation honestly is, well, trying to do continuous integration tests where you can, of course, but I think the better thing is to look at live data, because live data doesn't lie, and test data for performance is often a lie, much more so than other testing domains. So for example, Wikimedia, as an example, has lots of graphs to show like how long this page took, how long page rendering took, how long first paint navigational browser events were fired. And then every time they deploy code, they look at these graphs, and if there's a sudden spike, they know, well, whoops, something went wrong, we have to revert. Like, I don't know if I could show you that. So yeah, so like, as an example of like what can, some of these are effort tests, right? So like all things, testing is a trade-off between how much effort you want to spend and how much you're getting back. Sometimes that's worth it, but sometimes like effort spent on testing is effort you can't spend on like making a product better or whatever. So you have to always like measure it. Like for some people, a little bit of slowness, like that's acceptable because they have more important things to do. But yeah, just as an example, like Wikimedia keeps track of actual user data for testing, and you can see different network types. They also use something called ArcLamp, which is a profiler that kind of doesn't affect performance, so it can be run live, and it makes what am I doing for time? It makes pretty flame graphs, which are can be quite easy to kind of reason about, sometimes easier than raw profiling data. So yeah, I would say measure and try and measure with real data and make like alerts based on real data where possible. But oh, that's not the right one. Cool. Does anyone have any other questions?
I have a question.
Yeah.
Does anybody provide services where they would come in to an existing wiki production system and perform this analysis for us and make suggestions?
The guy named Brian Wolff is the best in the business.
Yes,
Well, that was a nice slow pitch down the middle, right?
Right.
I was actually hoping he would say that.
So, right. The question was, does anyone provide services to perform analysis and improvement of your MediaWiki system? I would say I work at Wikitech. Send us a line if you're interested in that. Send us an email. Yeah. I mean, there may be other people who do it as well, but I would recommend us.
And so if I could just add on to that, if anybody hearing this is interested in providing quotes on such a service, please add them as comments or reference yourselves in the comments to this, and we'll seek you out. Thank you.
Well, okay. I think we should move on.
Oh, okay.
Well,
Is there
15
time for-
seconds.
very quick. Okay.
Just want to say, there might be other companies that do this too. I don't know if they do it as well.
As well, right. Double meaning.
Just wanted to clarify.
So this was the flame graph thing I was talking about earlier. It's like a visualization of profiling data. Just showing it to you.
Okay.